In order to understand the generation of construction and demolition waste, let's first have a look at the life cycle of a building or a civil engineering structure. After the design phase, buildings or civil engineering structures such as streets, highways, bridges, and subways are constructed, for which energy and materials are consumed and construction waste is generated. Construction waste is normally composed of surplus material, damaged or broken material, cut-off pieces, dismantled shuttering and scaffolding, packaging, garbage generated by the people on the construction sites, and soil and sand from site preparation. This waste could be recovered or disposed of. Renovation, reconstruction, or repair might be required throughout the life cycle of the infrastructure. This again requires energy and materials and generates both construction and demolition waste, which is comprised of all the previous materials as well as rubble and mechanical equipment. Once more, part of this waste can be recovered or disposed of. Finally, demolition can result due to both natural disasters and man-made causes, such as civil conflicts and vandalism. Demolition produces a significantly different waste than construction or renovation. Demolition waste is composed of mixed rubble and debris, including wood, concrete, masonry, and reinforcing materials such as steel, which can be contaminated by undesirable components and or potentially hazardous substances such as lead paints, stains, and adhesives. This waste has traditionally been disposed of. However, it can also be reused to substitute virgin materials. So, how much construction and demolition waste do we generate? Let's have a look to the generation rates of the European Union, United States, Japan, China, India, and the Arab cities of Dubai and Abu Dhabi. The European Union seems to generate most construction and demolition waste, followed by the USA. But what if we now calculate the per capita generation rates? Wow! These numbers convey quite a different message. Note especially the high construction and demolition waste generation rates per capita of Dubai and Abu Dhabi, and the low generation rates of China and India. However, most published figures are mere estimates, and often countries do not report their actual generated amounts. Therefore, these figures need to be interpreted with caution. What we do know is that construction and demolition waste often represents the largest proportion of total waste generated in weight. In OECD countries, for example, it accounts for 34% of the urban waste generated as shown here. In terms of the individual components, we consider these 14 categories of materials as the main constituents of construction and demolition waste. You are welcome to stop this video for a second to have a more detailed look at the list. Let's have a look at some important concepts when managing construction and demolition waste. The very first step, as indicated in the waste hierarchy, implies preventing the waste. A simple measure to prevent waste during construction is to reduce the over-ordering of construction materials. Prevention during demolition has a lot to do with the design of the buildings and therefore requires thorough and timely planning already in the design phase. When buildings are designed for deconstruction at the end of their life cycle, more components can be reused and it prevents a lot of demolition waste. For instance, here we see the deconstruction of a modular building, where the different modules can be dismantled and their parts stored for further use. When talking about reuse of construction and demolition waste, we use the term salvageability. The salvageability of a material is defined as its potential to be reused in its current state, minimizing the needs for transport and further processing. Some debris might be used for backfilling of holes, for instance. Due to the variety of waste materials, it is important to segregate construction and demolition waste. This can be done at source, ideally, or in specialized treatment plants. This way, each waste stream will be managed as required. Here, we see how these operators have separated out all the metallic frames of this soon-to-be demolished building. Then, the materials need to be transported to, ideally, a processing plant for further reuse or a final disposal site. The next step in the hierarchy is to recycle or recover any materials. It is important to mention that when buildings or civil structures contain hazardous substances, they become much more difficult to reuse or recycle. When neither reuse nor any sort of recovery is possible, the waste needs to be disposed of. This is still the most common practice in low and middle income settings, mainly due to the high costs of the labor needed for reuse of the materials, the lack of expertise in reuse practices, the low cost of the new or virgin materials, the insufficient regulatory framework, not having any control over illegal dumping, and the low landfill fees. In spite of the multiple recovery opportunities, illegal dumping of construction and demolition waste continues to be an ongoing problem in high, middle, and low-income countries. Doing things right always pays off. There are many benefits of managing construction and demolition waste in a proper way. The recycling of this waste can create employment and economic activities. Just to mention an example, this sector created 230,000 jobs in the USA in 2007. It avoids costs by reducing the purchase of excess materials and disposal needs. It offsets the environmental impact associated with extraction of resources. It also helps conserve landfill space, and it avoids negative environmental impact of disposal, especially of construction and demolition waste contaminated with hazardous materials.